Okay, 6-7, day 2. What we're going to work on today is finding the exact value of angle measures that are not taken directly from the exact value chart or unit circle. We're going to continue working with the identities for cosine of alpha plus beta and cosine of alpha minus beta. Okay, so if you're asked to find the exact value of cosine of 7 pi over 12, we will tell you which identity to use, whether it be the sum or the difference. First thing you want to do, and you won't find all of them, you want to find sums that give you the value you're looking for. Okay, so you want to find two numbers that add to 7 pi over 12. So maintaining the common denominator of 12, just look for some combinations. 1 plus 6 would give you 7, 2 plus 5 would give you 7, 3 plus 4 would give you 7. So what we're going to do next, we have to determine which combination we want to use. Simplify each of the fractions from above. Pi over 12 doesn't reduce. 6 over 12 would reduce to 1/2. 2 pi over 12 reduces to pi over 6. 5 pi over 12 doesn't reduce at all. 3 pi over 12 reduces to pi over 4. 4 pi over 12 reduces to pi over 3. Alright? Now these are non-calculator, so the only way that we can find the exact value is by using known angle measures. So our reference angles of pi over 6, pi over 4, pi over 3, or any values from the unit circle. So 0, pi over 2, not 12, 3 pi over 2, 2 pi, and I skipped pi, should be in there. So it eliminates the first two combinations. Because of denominator of 12, we don't have the exact value for that. Choose the set that both values can be found on the chart or circle. We told you to use the sum formula. Alright, so the expansion for the sum, cosine of the first angle times the cosine of the second angle. Change the operation, sine of the first angle, sine of the second angle. Pi over 4 and pi over 3 are both first quadrant angles. Sine and cosine are both positive. Cosine of pi over 4, so square root of 2 times 1/2. Top times top, bottom times bottom gives me square root of 2 over 4. For the sine functions, top times top gives me square root of 6. Bottom times bottom gives me 4. Since the denominators are already the same, we can just combine the numerators. So this answer is the exact value of the cosine of 7 pi over 12. And notice that the answers look different than the exact value chart because they don't have a reference angle of 6 pi over 6, pi over 4, or pi over 3. Alright, find the exact value using the expansion for the difference of two angle measures. So first we have to list a couple combinations that would give us a difference of 5. So 7 pi over 12 minus 2 pi over 12. Alright, we're going to maintain the common denominator from the original problem. 7 minus 2, 8 minus 3 would give us a difference of 5. 9 minus 4. Okay, 6 minus 1. Now it's up to us to see which combination will reduce to one of our exact values, one of our reference angles. Well, 7 over 12 doesn't reduce, so that one's out. Likewise, 1 over 12 doesn't reduce, so we can't use that one either. 8 twelfths, both 8 and 12 are divisible by 4, so that would reduce to 2 pi over 3. 3 twelfths reduces to a fourth. 9 over 12 reduces to 3 pi over 4. 4 twelfths reduces to 1/3. Now you only need one combination. Okay, doesn't matter. Once you find one combination, you don't have to look for anything other. I'm going to use this one. Alright, so the cosine of 3 pi over 4 minus pi over 3. My identity, cosine of the first angle measure, cosine of the second angle measure. Change the operation, sine of the first angle measure times sine of the second angle measure. Now using what we know about the exact values, 3 pi over 4 is a second quadrant angle with pi over 4 as a reference angle. Cosine in the second quadrant is negative. negative root 2 over 2. Cosine of pi over 3 is a half. 3 pi over 4 being a second quadrant angle, the sign is positive, and the sine of pi over 3 is square root of 3 over 2. Top times top, bottom times bottom, top times top, bottom times bottom. Now the only different way you could see this is generally the positive radicals written first, so square root of 6 minus square root of 2 over 4. And that would be the exact value for cosine of 5 pi over 12. Okay, 13 pi over 12 using the sum and difference. Okay, 1 plus 12 would give us 13, but automatically 1/12 doesn't reduce. 2 pi over 12, that would reduce, plus 11 pi over 12, but that one won't. 3 pi over 12 plus 10 pi over 12. If I look to reduce this one, 3/12 reduces to pi over 4. 10/12 would reduce to 5 pi over 6. I have two appropriate reference angles, so we'll just go with this one. I just want you to see that as soon as you find a combination that works, then go with it. So cosine of pi over 4 plus 5 pi over 6. Cosine of the first angle measure. Cosine of the second angle measure. Change the operation. Sine of the first angle measure times sine of the second angle measure. 5 pi over 6 is the second quadrant angle, so the cosine value is going to be negative, the sine value will be positive. Cosine of pi over 4, square root of 2 over 2. Cosine of 5 pi over 6 would be negative root 3 over 2, minus sine of pi over 4, square root of 2 over 2, and sine of 5 pi over 6 is positive half. Top times top, bottom times bottom, top times top, bottom times bottom. Both values are negative in the numerator, negative square root of 6 minus square root of 2. So you don't have to worry about changing the order. Now you'll notice the exact values, you'll see the same thing, the same square roots popping up, because think of the answers that we're using. 1/2, square root of 2 over 2, square root of 3 over 2, square root of 3 over 2, square root of 2 over 2, and a half. So notice the combinations of the numbers they add to. You're only going to be using sine and cosine. You only find expansions for sine and cosine. So our tangent values, at least for this lesson, we're not going to use. Okay, 21 pi over 12 21 pi over 12 using the difference of alpha plus beta. You might spend a little time finding some combinations, but I know 24 minus 3 would give me 21. When I look to reduce these, 24 divided by 12 would give me 2 pi. 3/12 reduces to pi over 4. So this will be nice and easy to use as well. 2 pi minus pi over 4, cosine of the first, times the cosine of the second angle measure, change the operation, sine of the first angle measure times the sine of the second angle measure. Pi over 4, first quadrant, sine and cosine are equal. 2 pi is on the unit circle. The coordinates at 2 pi are 1, 0. So the cosine of 2 pi is 1 and the sine of 2 pi is 0. So 1 times the square root of 2 over 2 plus 0 times the square root of 2 over 2. 0 times anything is 0. If that's what our answer is, square root of 2 over 2, that is from our exact value chart. Sorry, this should be a 12. Which means 21 over 12 should probably reduce. So if I divide both of those by 3, this would give me the cosine of 7 pi over 4. Okay, 21 divided by 3 is 7. 12 divided by 3 is 4. 7 pi over 4 is a fourth quadrant angle with a reference angle of pi over 4. So it verifies that our answer is positive square root of 2 over 2. So the expansions can definitely be used even for angles that would appear on our exact value chart as well. Okay, last one. 15 pi over 18. Couple combinations that we could use. 21 pi over 18 minus 6 pi over 18. 21 minus 6 giving us 15. 18 pi over 18 minus 3 pi over 18. 18 minus 3 giving us 15. I'm going to reduce this one because 18 divided by 18 will give me 1 pi. 3/18 reduces to 1/6. Pi minus pi over 6. Cosine of the first angle measure. Cosine of the second angle measure. Change the operation. Sine of the first angle measure times sine of the second angle measure. Pi is up here on the unit circle. Coordinates are 0, 1. So the cosine of pi is 0. Cosine of pi over 6 is square root of 3 over 2. Sine of pi is 1. Sine of pi over 6 is a half. So this reduces to a half. Now think about reducing 15 over 18, both divisible by 3. So we would get 5 pi over 6. This should be negative. Five pi over 6 is the second quadrant angle. Okay, major mistake. Sorry. Pi is over here on the unit circle. Cosine is negative 1. Sine is 0. So, my apologies. That's completely wrong. Cosine of pi, negative 1 times square root of 3 over 2 plus 0 times 1/2. So now, when I look at the reduced fraction, 5 pi over 6 is a second quadrant angle. Reference angle is pi over 6. So now it verifies that my answer is correct. Sorry about that. Okay, so this is the end of day 2. So your homework would be the day 2 worksheet.